Welcome back, students. We have been doing algebra, and in that we are doing polynomials. In the previous video we have given introduction to polynomials. We have defined what is a polynomial, what is the degree of a polynomial, and we gave different examples of a linear polynomial, quadratic polynomial, cubic polynomial, and a bi-quadratic polynomial. And now what are we going to see is value of a polynomial at a point. So value of a polynomial at a point and zero of a polynomial. So that's what we are going to see. Now before giving the proper definition of value of a polynomial, let us consider a simple polynomial. A simple is expression or polynomial expression, namely x square plus, or rather 2x plus 1. You take a linear polynomial. I say that this is a linear polynomial because the degree of the polynomial is 1. Degree of the polynomial is 1. Now, what do we mean by value of a polynomial at a point? Now, what happens when x is equal to 1? If we substitute x is equal to 1 here, what will happen? So I am going to replace the x by 1 in this expression, in this polynomial expression. So what am I going to get is 2 times 1 plus 1. 2 times 1 plus 1. So 2 times 1 is 2, 2 plus 1 is 3. So the value of this polynomial at the point x is equal to 1 is 3. So value of this polynomial at the point 1 is equal to 3, or value of p of x when x is equal to 1 is 3. So this is what we mean by the value of the polynomial. Now what will happen when we substitute x is equal to minus 1, what happens? So value of p at the point minus 1. Value of p at the point minus 1. What I am going to do is I am simply going to replace x by minus 1. So I have replaced x by minus 1, and here also I am going to replace x by minus 1. So what I am going to do is 2 times minus 1 plus 1. So this is going to be minus 2 plus 1, which is minus 1. Now the value of this polynomial, the same polynomial, namely 2x plus 1, at the point minus 1 is minus 1. At the point minus 1 is minus 1. Now what happens? Let us see what happens to this polynomial when x is equal to minus half. If we give x is equal to minus half, let us see what happens to this polynomial. Okay, so when simply replace x by minus half, then you will get 2 times minus 1 by 2 plus 1. 2 times minus 1 by 2 plus 1, right? So you can cancel out these two. What you will get is minus 1 plus 1. So it is going to be 0. The value of the polynomial at the point x is equal to minus half is turning out to be 0. So we have a polynomial here, and we found the values at 3 different points, namely at x is equal to 1, the value of this polynomial is 3. At x is equal to minus 1, the value of this polynomial is minus 1. When x is equal to minus half, the value of the polynomial is 0. Okay? So, at which point the value of the polynomial is 0? That point is what is called 0 of that polynomial. Okay? So, here when you substitute x is equal to minus 1 by 2 here, when you substitute x is equal to minus 1 by 2, then the value of the polynomial at minus 1 by 2 turning out to be 0. That means the value x is equal to minus half makes this polynomial as 0. Then that value is what is called 0 of this polynomial. So the value of x for which this polynomial is 0 is what is called 0 of the polynomial. Okay? So that is the 0. So in this case, x is equal to minus half is a 0 of the polynomial of p of x is equal to 2x plus 1. So it's a 0 of 2x plus 1. Okay. Now we will define formally the value of a polynomial at a point and 0 of a polynomial. Okay. Now definitely let p of x be a polynomial. And p of x be a polynomial. The value of p of x at a point x is equal to k is called the value of the polynomial and is denoted by p of k So this is the value of the polynomial. Simply replace x by k in that polynomial, then what you will get is the value of the polynomial at the point k. Now we will define what is 0 of the polynomial. The value of x or the value of x for which p of x becomes 0 is called the 0 of the polynomial. Polynomial p of x. That is, if we want, we can if x is equal to k is a real number such that p of k becomes 0, then x is equal to k is a 0 of the polynomial p of x. Okay, right. Now there arises a question. Do polynomials should have 0 always? Do they have 0 always? Not necessary. A polynomial may be 0 at some point and it may not be 0 at every point. So it may happen that a polynomial may be 0 at some point or may not be 0 at every point. For example, you take a polynomial p of x is equal to x square minus 1. You take this polynomial. What happens when x is equal to 1? So when x is equal to 1, what is p of 1? P of 1 is 1 square minus 1, which is 0, right? What happens when x is equal to minus 1? So p of minus 1 is equal to minus 1 square minus 1, which is again 0. So this polynomial becomes 0 at 2 points. So the value of the polynomial becomes 0 at these 2 points. Therefore we can say that x is equal to minus 1 and x is equal to plus 1 are zeros of this polynomial. P of x is equal to x square minus 1. Now you look at the degree of the polynomial. What is the degree of the polynomial? 2. So if the degree of the polynomial is 2, this polynomial can at the most have 2 zeros. If at all if this polynomial takes the value 0, then it can take only maximum at 2 points it can take value 0. So degree of the polynomial conveys a fact to us. What is that? It conveys a truth. It conveys a secret to us that if at all a degree of the polynomial is 2, it can have at the most 2 zeros, namely -1 and +1 for this polynomial. Sometimes it may happen that it may not have zeros at all. Now we will give an example of a polynomial which do not has zeros at all. For example, you consider a polynomial. X square plus 1. If you take this polynomial, comma, you take x to be real number. Whatever may be your, see, the real number means x can be positive, x can be 0, x can be negative. Okay? X can be positive, x can be 0, x can be negative. Now I am going to give x is equal to, let us take positive value. Let us take any positive value, k. X is equal to k. K is greater than 0. Okay? K is positive. What will happen? So q of k is k square plus 1. So square of a real number is always positive. Positive plus positive, this is greater than 0, right? So in the first case, when x is equal to k greater than 0, it is positive. So it is not a 0. So this is not 0, right? And this is not going to be equal to 0. Likewise, when k is 0, when it is 0, you give x is equal to, or for example, you can take what? You can take any positive number rather, not even k. Here, you take any positive real number. For example, you take 1. What will happen? 1 square plus 1 is 2. This is 2. This is not equal to 0. When you substitute x is equal to 0, what will happen? 0 plus 1. But this is also not equal to 0. When you substitute, this is when x is equal to 0. When you substitute x is equal to -1, what will happen? Q of -1. This is q of plus 1. Q of -1, what will happen? -1 square plus 1, which is again 2, which is not equal to 0. So this polynomial is not going to be 0 at any point. At any real number, this is not going to be 0. So this polynomial has no zeros at all. Where? Whenever you give real values of x, at no point, at no real number, this polynomial becomes 0. So this is an example of a polynomial which does not have zeros. Here. Okay? For no real number, this can be 0. Whereas this polynomial has 2 zeros maximum. So degree conveys an information to us. If at all the polynomial has zeros, it cannot exceed the degree 2. Okay? So that is what is the value of a polynomial at a point and the 0 of a polynomial. In the next video, we are going to see what is the meaning of, geometrical meaning of 0 of a polynomial. Okay?